Okay, this is 5.5C College Algebra, page 486, Solving Systems of Equations. Alright, first of all I'm going to start out with comparing regular old algebra math problem to what we're doing with matrices, just to see if it helps you understand. So let's say that we have the equation 8x equals 24, and we're going to compare that to a matrix. Okay, remember back in the last lesson, we just brushed into this on page number, what was it, 477. And we can write a system of equations as ax equals b, where a is our matrix from our numbers, our coefficients from our system of equations. Our x are our variables, x, y, z. And the b are the answers there. So if you look back on the bottom of page 477, you'll see that. I won't write it down. Alright, so let's do the math. If we're looking at solving for 8x equals 24, you have learned to divide both sides by x, which is true, but it also means that we can take both sides and multiply it by the inverse of what we're trying to get rid of here. So I can multiply 8x by 1/8, and that is 24 times 1/8. Okay, so if I do that, I'm multiplying my 8 by its inverse, or dividing it by itself. Same thing. Which I'm going to show over here on the right. If I multiply a by its inverse, and I do it to the other side as well, I get that. Okay, so all I did was showed in letter form that I'm taking the inverse and multiplying it by a, the inverse and multiplying it, and then multiplying the other side by that inverse. Okay, so let's keep going here. So now I have 1x equals 1/8 times 24. Okay, I just switched those around. I don't know why. But anyway, that just is 1/8 times 24, which is very similar to the identity, because when we multiply these two, we get the identity, right? Times x equals a to the negative 1b. Now I have 1x equals 3, and over here, actually I don't have 1x. Let's go ahead, and because that just is a 1, we can get rid of that, right? So we're going to do the same thing here. If it's the identity, we're going to get rid of it, and that equals a to the negative 1b. Okay, very important equation there. That's just showing you how we got what's in that blue box there on page 486. For a system of n linear equations and n variables, ax equals b, if A is an invertible matrix, then the unique solution of the system is given by x equals A inverse b. Okay, so all that is to say, let's go to example 5 and use this formula and show how to, let's see if we can get rid of some of this, and be able to use this formula. I have that arrow pointed to solve the system of equations here. So we have negative 2x plus 3y equals 4. I also have negative 3x plus 4y equals 4. Okay, so I'm going to write this out in as an equivalent matrix equation, and then I'm going to explain something a little bit better here, because I think it'll make it easier once I have this written down. Okay, so that's my A. My B is going to be, or my X is going to be that. And then my B is going to be this. Okay, so if you remember from the last lesson, what we said was AX equals B. Alright, so when I have a system of linear equations with that many variables, so if I have two equations with 2 variables, 3 equations with 3 variables, 10 equations with 10 variables, I can write it in the form of AX equals B. Okay. The solution to this system of equations, if I want to know what X is, and if I want to know what Y is, because that's actually what I'm finding, right? With a system of equations, I'm trying to find out what X and Y is. If I want to find those two, all I have to do is solve this. This will give me the answer, because see, A inverse times B gives me this right here. It gives me the numbers that represent the X and the Y, because see, this capital X represents the lowercase x and the lowercase y, what I'm looking for. So if AX equals B, and I convert it to this format right there, and I multiply the inverse of A matrix times B, which is right here, I am going to get my X value and my Y value. So the first step in solving this, find the inverse of A. If I can find the inverse of this, multiply it times this, I'm going to get this here. Okay, I hope that makes sense. So in a previous lesson, in fact in example 3, we found A of -1. We found the inverse of -2, 3, -3, 4. And when we did that, we found that this was 4, -3, 3, -2. So now, knowing that, if I take this right there, 4, -3, 3, -2, and multiply it by B, and here's B right here, 4, 5. If I multiply those together, first of all, let's see if we can. This is a 2 by 2, and this is a 2 by 1. So that means I'm going to get a 2 by 1 for an answer. So I'm going to get a matrix that looks like this. Sorry, put it over here on the other side. A 2 rows by 1 column. Okay, so the top number will be my X and the bottom number will be my Y. So let's go ahead and multiply those. I want to multiply these two together. My inverse of A times my B, and that will give me my X according to what I had right here. So first thing you're going to do is you're going to find the inverse of your A, you're going to multiply it by your B, and then you're going to be done. So let's see if I can get some of this junk out of the way and move it around for me. Alright, so there's the matrix that I'm trying to multiply right there. And again, it's a 2 by 1. My answer is going to be 2 rows, 1 column. And let's do this in green. Maybe you can see it better. So what we're going to do is we're going to find this number here. First row, first column. First row, first column. 4 times 4 is 16, plus -15 gives me a 1. And I'm going to look at second row, first column, second row, first column. 3 times 4 is 12, -2 times 5 is 10, 12 minus 10 is going to give me a 2. There's my X and Y. So, some of you were saying, I'd much rather do systems of equations than do this whole Gauss-Jordan elimination method. Well, this wasn't so bad, was it? The only time you use your Gauss-Jordan elimination is to find the inverse. Once you find the inverse, you multiply it by the answer, your B, or what we have right here, and you multiply those two matrices together, and you're done.